Honors Algebra, Mr. Lawrence here with your flipped lesson for Monday, March 12th. Going to do two problems from the worksheet. First of all, I'm going to start with page 289, and it's problem number 53. Okay, so if you've got your packet with you, you can see how to do this one. The length of Jillian's rectangular garden is 12 feet greater than its width. So I know that if the width is W, the length is W plus 12, right? Consequently, the area would be a product of those two, or W squared plus 12W. She wants to plant some flowers next to the garden. She decreased the length by 5 feet. Well, that means the new rectangle, its length is W plus 7, right? And she increases the width by 2 feet, W plus 2. All right, and so the area of that would be W squared plus 9W plus 14. How did I get that? I FOILed the quantity of W plus 2 times the quantity of W plus 7. All right, if the area of the garden was decreased by 55 square feet, so what that means is that the black one, which ends up being W squared plus 12W, is 55 feet greater than the red one. So W squared plus 9W plus 14, and then I'm going to add a 55 on here to make them equal. The black one is 55 feet greater. All right, so I'll simplify this, write it all as 1. W squared plus 12W equals W squared plus 9W plus 69. Don't make a mistake like I did and get 73 there. I was working on my answer key and did a silly thing like that. Now, if I subtract W squared from both sides and subtract 9W to get all my W's over to the left, and then I will already combine like terms, I will be left with the equation of 3W equal to 69. And therefore W must equal 23 feet. If that's the case, then the length being 12 longer will be 35 feet. Now, on the new one, the width was increased by 25, or by 2 to 25 feet, and then that was decreased by 5, the length to 30 feet. If I'm right, if I find the area of the black one here, and the area of this, the difference should be 55. And sure enough, if I multiply 23 times 35, I in fact get 805. And if I multiply 25 times 30, I get 750. If I subtract those, sure enough, I will get 55. All right, so I know the original dimensions are 23 feet by 35 feet. Okay, I am going to flip over a couple pages here, and I am on the page now that says lesson 7-9, solve equations by factoring. It doesn't say it at the top or at the bottom. It actually says it close to the top under problem 37. There's problem 36, 37, and then that heading there. Okay, I am going to look at problem number 38. And it says the square of a number subtracted from 8 times the number is equal to twice the number. Well, I need a variable, so I'm going to let n equal the number. I need the square of the number. Well, that would be n squared. I need to subtract it from 8 times the number. Notice it doesn't say subtract 8 times the number from n squared, from the square. Subtract the square from 8 times the number. And that's the same as twice the number. Well, now I'll get all my n's on the same side. Subtract 2n, subtract 2n, and I'll end up with 6n minus n squared, and that will equal 0. I'll factor using the GCF, which is n, And then I have two possibilities. I can solve this for n, and I can solve that for n. So n equals 0. Whew, that was a hard one. That was this one here, right? Now for the second quantity, I have 6 minus n equals 0. Subtracting 6, negative n equals negative 6. Divide by negative 1, and I will get n equals positive 6. So my choices are n equals 0 or n equals 6. I can test them. All right. I can test them. I think I'll test them in green. I'll do 6 times 0 minus 0 squared equals 0. And of course, oh, I should back up. I shouldn't test it with that line. I should start with the previous line. Sorry about that. I'm going to do 8 times 0 minus 0 squared equals 2 times 0. And of course, you should see that you get 0 equals 0, which is a true statement. So that one checks. Then I'm going to test it with 6. 8 times 6 minus 6 squared equals 2 times 6. Well, that's 48. 36. And that's 12. Is 48 minus 36? It sure is. Excuse me, 48 minus 36, is that 12? It sure is. There you go. There's your two solutions. All right, real quick video. If you need to watch it again, that's fine. On number 40, I want to give you a small hint. Number 40 says, write an equation with integral coefficients that has set 0, 7, negative 3 as its solution set. That's a backwards problem. You work backwards. You start from here and work backwards. If I have n equals 0, I know that n is one of the factors. If I have n equals 6, I could subtract 6 from each side and get n minus 6 as a factor. Okay, that's the approach. You're not going to do that with those numbers because the set is 0, 7, negative 3, but you're going to work backwards on it. All right, that's a real quick lesson for you. Mr. Lawrence signing off. Have a good night, everybody.